Now, let us look at the steps of how you're going to solve the linear programming using the corner points. First thing, identify the function to be maximized, minimized. Then define your variables. Write an objective function, okay, and write a system of inequality. This one you have no problem. And then now the terms here, the step 5 is sketch the feasible region. And later on, you're going to the step 6, determine the coordinate for each of the coordinate for the each corner points of the feasible region. And the last one is evaluate the objective function at the each corner points and determine the optimal solution. This is the one I highlighted in the red one actually is the something new. Okay, so like you have a corner points and so on. Okay, how this really happen is, let's say you have the question is a fair furniture company. You have two products. The first one is chair, the second one is tables, and the decision is how many of each to make this month. The objective, you want to maximize the profit. So the data they provided to you is you're going to earn the profit 7 RM for per table, RM5 per chair, and then you have a carpentry and you have a painting and so on. So, and then they have the others limitation. They said that you cannot make more than for 450 chairs, and you cannot make and then you must make at least 100 tables. Okay, so first thing is we need to identify what is our decision variable. So actually you can use x1, x2, but here I choose T stand for table, C stand for chair. Okay, so the numbers of the tables you have to make and the numbers of the chairs you have to make, and then you have to identify the objective function. The objective function actually is you want to maximize the profit. Okay, so we can write as a maximize Z, okay, or you want to say that maximize P also can. P stand for profit, doesn't matter. And from the previous slide, we know that table you can earn 7 RM and chair you can earn RM5. Okay, so this is your objective function. And from there is we change it into here. Then from all the data they provided you, you can form this four different inequality. And you have to remember thing, because table and chair is something that cannot be negative. You cannot say that you want to build negative one chair. How to build a negative one chair? Okay, so that's why you yourself have to tell that you have the table and chair must be greater and equals to 0. You can build 0 chair, means that you build nothing. But the thing is you cannot build negative 1 chair. Okay, then this is the step from 1 until 4. Then now we sketch. Okay, the sketching is, let's say I have a x-axis, I have a y-axis, and I roughly sketch, I giving the 1 bar equals to 2, 4, 6, 8. Even you want to use ruler to calculate to divide them into the equal part also doesn't matter, 2, 4, 6, 8. And this is more or less is like the last time what you did. If you want to plot 3t plus 4c, so what we will do that is let t equals to 0. So actually your c is 600. So this is stand for the 600. Okay, and then after that C is 600, and then let C equals to 0, your T equals to 800, so T equals to 800. Okay, and then this is a 600, so you draw a straight line using the ruler to draw a straight line, and you draw 1, 1, 2, 3, 4, and T and C greater than 0. That means you only draw it in the quadrant 1. And then after that, you need to make sure they fulfill all the inequality. So this is the shaded part. Okay, now step 5 finish. Okay, now it's going to the step 6, determine the coordinate for the each corner points. Okay, so I over here I already shaded the one shaded is yellow. So I'm going to have A, B, C, D, E, 5 corner points. Okay, so the A is easy. Okay, A is actually here is 100. Okay, because this line actually is x equals to 100. So this is 100, 0. And over here, because this is actually is y equals to 450. So this B actually is 100, 450. And C, okay, C, if you look at it, is this yellow line intercepting with my blue line. Okay, so what is this blue line? This yellow line. This yellow line is 100. So you substitute x equals to 100 into the yellow line, blue line. So you're going to have your C. And then what happened to the D and, okay, the D, what's going to happen to the D? D is, these two lines are intercepting, so you solve simultaneous equation, you will get 320 and 360. And the last one is over here is the 450. So you have all these 5 points here. Okay, so this is all the respective corner points which is for this feasible region. Now, what next thing you need to do? Evaluate the objective function at each corner points and determine the optimal value. Okay, so this is the objective function. You take the value t, this is 100, and substitute 0 inside. Okay, then you press your calculator, then you will get obtain 700. And then you do repeatedly for all this one. Okay, either you want to show the calculation or you don't want to show the calculation, doesn't matter. Okay, but if you didn't show that, is you also don't have the chance to recheck, right? Okay, so after you calculated everyone, then you look at this number 700, 2950, 3650, 4040, 3150. And now, which value is the maximum value? Because you want to maximize the profit, the maximum value here is 4040. So at the side of it, you put an maximum here because you are telling me this is the maximum value, but you need to give me the conclusion. Making the 320 tables and 360 chairs will give the maximum profit. You don't stop here. You don't stop here, then you didn't give conclusion. How should I know that what is the max here, meaning what it means by this max? Okay, so then you already finished solving your linear programming by the corner points. Okay, now let's look at the second equation, second example. Okay, this also the same thing. Okay, now same thing here, you need to give x. Let's say this one I use x1 for the space rate, x2 for the zapper. Objective function also the same, maximize the profit, and then after that, so the value here is the one from the previous one. Then this color, okay, the respective color is representing the points, the lines. Okay, so now after you have this visible region, you need to identify you have how many corner points. 1, 2, 3, 4. Okay, actually this D is here is 4 and 5. So 1, 2, 3, 4, 5. Okay, because this one is a bit small, so you better watch out. Okay, so because you need to find the correct intercept point. So basically you also cannot roughly sketch that until you cannot see which line is the correct line. Okay, so now how you find this point? Basically, you see whether they have an intercept or not. Okay, and what you need to do next? Okay, substitute the respective value inside the objective function, and you see here 4360 is the maximum among them, so then this is a max. Okay, then you need to tell 360 weekly product level of space rate, and this one will give you the maximum profit. Okay, so now before we go to the next one, then you can tell yourself that it's actually basically nothing new. Okay, the only difference is you're going to sketch, you're going to get the corner points. Okay, last time you no need to find the corner points. Now you need to find the corner points. Okay, how to find the corner points depends on the points where it located. If they fall in between two inequality, so how to find the intercept point between two lines, that means you just solve by simultaneous equation. If they located at one corner, like this one, we know it's a 0, 0. Okay, please don't drop 0, 0. Okay, 0, 0 is a corner point. Okay, or like here, if located at the y-axis, that means your x is 0. Okay, this is the thing that you should know. Okay, and now we look at the second, this is the special example from the textbook. Okay, let's say you juice stand sells 2 types of fresh juice. Okay, and then you have a so and so limitation. Okay, so the goal of this one is to stand to maximize the revenue. What is the maximized revenue? Okay, they ask you what is the maximized revenue. Okay, so now from there, you form this inequality. So you sketch everything. Okay, so you got how many corner points? 1, 2, 3, 4, 5. You have 5 different corner points. Okay, so these 5 corner points. So our corner points. And you substitute into each 6x plus 8y, substitute in. Like just now I said, whether you want to show how to calculate, or you can straight away key into your calculator and give me this one also doesn't matter. Okay, from here, over here, this one, and then it said that hence E is the largest value. Okay, this is the largest value here. Okay, so the way to generate optimal revenue is produce 15 refreshers and 3.33 super duper for a total revenue 116.66. Okay, now, but here they have a telling you that this solution is not feasible because we can only produce whole number quantity of drinks. Okay, so we need to round down y to make sure we stay in the feasible region and report an answer of 15 refresher and 3 super duper for total revenue of 114. Okay, so if you explore more and so on, then you can see that you have a 116 and so on. Okay, so in general, dealing with integer constraint is very tough. Okay, so in practice, if there is an R integral constraint, the best way to proceed is to solve the problems without worrying about this additional constraint, then look the nearby integer points to find the maximum. So means that, let's say, if you really encounter problems that, let's say, it's a 1, 1, like just now, you have a 3.33, then you just round down. You cannot round out. When you round out, you're already out of the feasible region. Okay, now, this one also another one example with many solution. The same question, but the thing is they just change the sum of the value. Let's say this is a 9 ringgit and 8 ringgit. Okay. So what is the maximum revenue? Okay, the corner point is not going to change, okay, because this one 9 and 8 is actually s at the z. Okay, if you see that is these two giving you the same answer, 5, 10 and 15, 10 over 3. They are giving you both the same 120 and 120. Okay, so actually there is a whole line of solution because the new revenue 6x plus 9y is parallel to constraint 2x plus 3y equals to point T that joins A and E. Okay, so this is another one example. Okay, then the last one here is example with unbounded region. Okay, so a politician and so on and blah blah blah. Okay, so this one is called the unbounded region. Okay, so because this question is wish to minimize. So if minimize, you have no problem because this is your corner point, this is your corner point. Unless the question is maximize, so you don't have the maximize part. You only have a minimum part. Okay, so there's no problem. Okay.